This conference will now be recorded.
Okay, all right. Thanks everyone. Okay. So for today, right? My plan is, or for this week, today and this week. Okay. See, our goal is to, right? Let me talk through my goal. Our goal is to make you AWS full stack engineer. Okay. The reason is it's a complete enablement program which makes you ready and place you. Right. That's our program. We are not just training here, spending time with you guys just to train you and leave you there. Right. Our goal is to place you in the market. Right. Our company Predactica, we have we have a few products in the market. You can go and look at my our company on the website, right, if you want to. So which is a analytics AI ML product company. We started the ML company a few years back, and if you see, we have some products: machine learning studio, customer studio, CX customer experience studio. There are some platforms, right? We are building solutions. We have pretty much, we are marketing even our, the whole thing is there, right? So again, that's how we started 3 years back, and we have built some good products which we are marketing in the marketplace. Okay, and we have a end-to-end, completely hands-free machine learning platform, starting from data ingestion all the way to building models and deploying it on cloud, on AWS cloud. Okay, and that's our one of the major platforms. We also do have NLP platform, natural language processing, using deep learning, all that stuff, which you use for building things like customer metrics. Okay, customer, as you see here, what if analysis, customer journey insight, all that stuff. But I just wanted to give you idea, right? So we started as a product company, but in the last couple of years, we have kind of, I won't say switched to, but we have added our services side, because myself, Vijay, and we have another person here, right? We all are in the technology field, so we have a lot of experience in this big data analytics, machine learning, as well as cloud technologies. All three, we are experts in those areas. And since our product is completely cloud and what you call machine learning and AI based, so we are building this service arm where we have already have around 25 consultants working. But this specific effort, what we are doing right now, is building cloud based expertise, where we can take in-house project from next year and execute it within our ecosystem. Okay, not just place somewhere, but we'll have execute within our own what you call in-house, I would say in-house projects and all that. So that's the kind of goal. So that's why the training is geared towards not just training, but to make you market ready. Okay, so we are making you AWS full stack engineer. So what does that mean, right? What does that, just kind of laying out what does that mean, why we go this path, right? So of course you need the AWS cloud foundation, right? When I say cloud foundation, what do you have in the cloud, right? Things like you need to know the storage, networking, right? These are the very key capabilities within the AWS or Azure, any cloud you go, right? Storage and networking. Then we'll talk about some of the database stuff, right? Which is the, on AWS we have RDS and all that, right? We'll go over that, and we have some other databases, the DynamoDB, right? For your NoSQL and all that, right? Then third thing, so that will kind of build your, of course there are other things are there. I'm not getting into the ELB, the load balancing, your monitoring, logging, all that stuff, right? Those are all good things that you need to know. So you need to have good foundation on the platform engineering side, right? Then what? Then second thing comes is your, what we call AWS data engineering. And by the way, these topics will be covered by Bijay starting next week. Okay. So AWS data engineering, this is where how to bring everything together to solve a industry problem. Just knowing this, yes, you can become a cloud platform engineer, provisioning different services, managing it, auto scaling in, scale out, all that stuff you could do, right? But that's not where everything ends, right? Most of the use cases in the industry is data specific, right? How to move data into cloud, create different industry solutions. What do we do in the industry anyway, right? You have reporting solutions. Even before reporting, I would say data lake solutions. If you have any of you in the big data area, you create data lakes, build data repositories, right? You have enterprise as a company, you have a lot of tons of data, transactional data, lookup data, all that stuff is there. You want to build a storage to put my terabytes and petabytes of data at one place and don't have to worry about scaling out if my data size goes bigger, right? Which is growing pretty fast, right? So cloud is the best place because you don't have any limitation in provisioning any new storage or compute, right? It's just the endless, right? You can pretty much have anything you want. You just have to pay for what you use, right? So data lake solutions just for the storage, storing your enterprise data. Then many companies beyond that also do reporting or analytics, right? Reporting and analytics. This is very common. 70–80% of the use cases I see, once they have the data, what do you want to do about it? Doing analytics, reporting. Okay. In fact, 90% of the projects or the what you call job descriptions that will, when you will apply, they will involve some kind of reporting. And again, you are not going in as a reporting person. If you have reporting knowledge, great. But you are not going as a reporting person. You are because you are the data engineer to prepare the data for reporting analytics. You are the backend guy. Okay. And that's where most of the demand is in the industry. That's where most of the money is. If you look at the salary or that stuff. That's why, because you are the main guy who is doing the magic to create the data ready for consumption. Okay. There are other use cases, AI ML, which is again picking up big time. By the way, myself, I also work here. It's not like I work for CBS as an enterprise architect there. And AI ML, most of our use cases currently we are on GCP, Google Cloud. We have also Azure because CBS does not go with Amazon because they're competition, right? Which is a pharmacy, right? Amazon has its own pharmacy, right? So most of the use cases I have worked on, our end user use case is AI, mostly building models and all that. But there is a lot of legwork that needs to happen to prepare the data, and that's where data engineers come in. Okay, and so AI ML, how you use it, or even reporting. These are the primary use cases I have seen. Okay, 90% of the use cases you will see around that. So that means you need to know the data engineering aspect, how to prepare the data, right? So that's where we'll focus a lot towards the end, right? Not towards the end, but after 3 weeks, we'll come to this side. Okay. And good thing is there are tons of services within AWS which it does it. If you people, those who are already aware of those services, of course, there's S3 or storage. You have, I'm just giving, so EMR is Elastic MapReduce for doing a lot of big data stuff. You have AWS Glue, right, where you can write programs, ETL jobs you write, right? You have, Redshift to do a lot of this reporting, which is the massively parallel processing platforms where you can build your what you call historical reporting, right? Think about our typical data warehouse. Okay, that's your Redshift. And there are many other services, NoSQL database like DynamoDB, all that stuff. But right, Athena, there is another service which we will be teaching. So these are the major services. If you apply for job, if you know these 4 or 5 things, you will get 10 different responses right away. I've seen this is where major requirement. People, those who know to move around data, okay, using these technologies. Okay. and of course there's a quick site and all that for reporting. But these are the major requirement we see in the industry, and this is where we'll be focusing a lot once you have good understanding of the platform, okay? which is Bijay is going to cover very detail. Okay, and on top of that, of course, we go do a little bit of AWS DevOps. Any development effort is there, you need to know the deployment, the build and deployment is critical, right? So how to use Git repo, right? How to use Jenkins, how to use something called Terraform, what sorry, my audio got disconnected for a minute. I think I'm back again. All can hear me, right?
Yeah.
Okay. Sure. So Shubham will come 1 weekend. He will completely focus on that. Okay. In terms of, so why are we starting big data today? Now you say, okay, it's all good. Why are we learning big data? Good question, right? I know I'm just, why are we learning big data? So it comes in here, okay, the data engineering, right? We were making you, because since our focus is to make it good data engineers, it is important for you to know the underlying, I would say, the technology that AWS uses to do most of it. It's ETL. ETL is extract, transform, and load. To do the data transform, am I audible? Okay.
Yeah, just for you.
Yeah, I think I'm breaking up and all that. So I think it's something with my Wi-Fi looks like. Okay. So sorry about that. Hopefully things will be better. So okay, good. So as part of this course curriculum, we want to know a couple of technologies which will help you build this what you call data pipeline. Okay, you are data engineers building data pipeline for batch processing. You are building data pipeline. You will be hearing these terms more and more. Data pipeline, this that. So don't worry, you will be hearing more and more. You'll get used to it. Okay, and so a couple of technologies you need to learn, couple of languages you need to learn, or one, right? Of course, Python. Right? So we'll be using Python heavily. The reason we are learning Python probably next week or sometimes we'll learn that. If you know, that's great. Again, the goal is not to make you Python expert, to get you started on this, and so that you know enough to start coding. Okay, and Python is very easy language. You like it, and for that we'll be using something called PyCharm. I'll send you the instructions how to install PyCharm. Okay, it's the IDE. And you can do that pretty much everything from your Windows development, studio, or you can select by its major development ID, what you call UI based development environment. Okay. Other thing we are going to teach you is Spark. Okay. If you see the AWS Glue and EMR, these are all, or EMR here. EMR is nothing but Elastic MapReduce, which is nothing but, yes, you can use Jupyter Notebook as well, of course. Yes. So EMR, Elastic MapReduce, is nothing but Hadoop on AWS. It is a Hadoop technology on AWS, right? And when you are learning big data on cloud, right, which is AWS, which is EMR, one of the main technologies that comes into picture is called Spark. You might have heard about it if you are coming from big data area. Apache Spark. Okay, so Apache Spark is a kind of universal processing framework in the industry right now. Okay, if you are running Cloudera, Hortonworks, any on-premise big data platforms in your in-house, like in CVS, we have Hortonworks, close to 2000 node cluster after CVS bought Etna last year or a year before. We have close to 2000. Most of our projects right now on Hortonworks. Most of our programming, everything happens in Spark and PySpark, mostly Python and Spark, although there you can do with Scala and Python, Spark as well. For this course, we'll be focusing on PySpark, okay? Python and Spark. So that way we'll kill two birds with one attempt, right? We'll make you big data engineers, same times you will be able to do this stuff as well. AWS has adopted PySpark and Python big way for its ETL. Since you are a data engineer, you need to be building the data pipeline, creating business transformations, doing data cleanup, data curation, data transformation, data building the reporting layer, all that stuff. You need a programming language and ETL, right? So this is where you'll be using your Python and Spark knowledge to build those pipelines. And we'll be doing that in the project phase. Okay, how to build it, we'll do that. Right? So that's the reason we are teaching PySpark and Python and big data component, right? We are not going to teach every component of big data. I don't feel a need because we are not making you purely a big data engineer. Our goal is to make it to AWS engineer. The two topics I will cover, go deep, is Hive and Spark, not anything else. I'm not going to cover the rest of Scoop and all those stuff. It's not needed, at least for my on my AWS. I don't need it. AWS has many other features to do all those stuff. I'm not teaching Flume. I'm not teaching all those, but these are the two core. In fact, if you go to even for the big data engineer in the marketplace, these are the main skill sets you need. 90% of the skill sets is around this, work is around this. You store the data in Hive, you process with Spark. Those are the two things. Yes, there could be a little bit of Scoop and all that if you are talking about on-premise big data engineer. But our focus is AWS is on the cloud. So we'll make sure you know the enough to do everything on the cloud, so that you can become a good big data engineer on cloud. Okay. So Hive and Spark. So this is what we'll be covering this week until next Sunday. Starting today all the way next Sunday, we'll cover Hive and Spark. Of course, with the introduction that I will do today. We're not going deep into the topics today, individual ones, but I'll do that tomorrow. Hive and HDFS a little bit, but we are not this. I used to teach. I am big data since 2014. I have probably taught more than 300 or 400 or 350 students in big data in last 5-6 years, and so I have and I used to take like 6 to 8 weeks just to teach big data. Okay, and here I am talking about teaching you in 1 week. Yes, we are doing this because we are focusing only couple of things, and I believe I have become very good at, because I have done so many times. I know how to make you ready for that. Okay. So anyway, so those are the, so we teach you even if you ask me, Hive is not even important for EMR. Just Spark. You just go deep into Spark. Okay, get a good Spark engineer, and along with big data AWS, you will land a very good job. I can promise. Okay, so that's the many of my big data students, they are working all over right now. I mean, at least 50 of them in my last 5 years. They're making good money. They're working all over, right? So anyway, so and DevOps, of course, the Shubham will come one weekend. He's one of the who has 6 certifications in AWS. He'll teach. He will come and teach you these 3 things in one of the weekends. Okay, so that's the kind of layout. Now you know why we are teaching. At the end, you will be actually building glue jobs using PySpark and creating data pipelines. That's the project will happen. Okay, At the end, you will build a project, one for batch pipeline, one for real time. 2 projects you will do that will require you to build these pipelines, right? From storage to this to this, this to this, right? Using all these things I'm talking about. So these are some of the services you'll be using to build your couple of pipelines using a batch process, creating batch process, as well as a real-time, what you call batch pipeline and real-time pipeline. When you do that and go to the interview, you will have much confidence. Yes, I have done it. I know how it works. So the difference is it's a small scale and the industry will be a big scale, but at least you, from quality standpoint, you know what to do. Okay, so that's the confidence we want to build, so that when you go to the interview, when you're talking, you know what it is. Okay, you'll be able to explain it, your project, in the same way, the way you have done your project. Okay, so that's how we do it, and because we are able to do it efficiently because we have done it many times and we work in this field. Okay, that's the reason. Any questions so far? So this is our kind of layout, and this week we'll try to go deep. So as I said in the beginning, right, today and this week we will cover, of course, today is big data introduction. With little of HDFS, it's not needed, but it's without, I cannot jump directly to Spark without teaching you, giving you some level of what is called HDFS and MapReduce. I have to give you some knowledge, although it is not needed in AWS. There is no, yes, there is HDFS in EMR, but mostly you'll be using S3, by the way. Nobody is using EMR HDFS storage, at least in AWS. Very rare people use S3. So since our goal is you will be AWS engineers, I'm not going too much into other big data technology. Now you know why. But Spark is what we'll focus a lot. Okay, Spark is where we are. Our main goal is to reach to this point. Okay, to get there, I cannot jump directly here. I have to teach you this thing. My goal is right. My goal is this, the third one, this slide. But I cannot jump here without telling you what are all these. It's just the overhead. If you ask me, it's the overhead. I'm able to do that, of course. And we have to, since we are here, we'll just learn a little bit of Hive as well. But again, we are not going too deep into Hive if time permits. Okay. But my goal is to spend most of the time in Spark, which will help you in as a big data engineer on premise as well later on if you want to. But I want to make you really good in Spark. Okay. So that's my goal. Not these ones. These are just foundation, I would say. These are all foundation, so that you can do this better. And you take that knowledge, do the same thing in here. Okay, these 2 things. Or you are, even if you're a platform engineer, if you're writing Lambda scripts, right, Lambda functions, right? There also you can like writing some Boto 3 scripts, right? There is some automation scripts you write, all those things. Python will be used heavily. So if you're a good Python engineer, you can write these things easily, or at least copy paste. At least you'll understand what it is. Okay. So that's the kind of approach we are taking. Okay. Any questions so far? Otherwise, we'll go to big data introduction. It's 10 o'clock. Okay, good. 1 hour we kind of talk about introduction. We may spend another 2 hours today, not a whole lot. And initial go little slow, but we'll catch up very quick. Okay. By next week, I'll be running fast. Okay. Any questions?
Hey, Ratikus Johnson, what about the weekly classes? What's going to happen on
weekly classes? What
will be happening during the week? Is the main class only on Saturday and Sunday, or
no, weekdays as well? There are 3 days weekdays as well. With this week also we have 3 days. I will let you know whether it's Monday, Tuesday, Wednesday. Again, we can agree on that. I am flexible. Any of these 3 days, we're fine. Okay.
So you'll be teaching the same thing during the week too?
Yeah. because we want to, if you just depend on the weekends, we will not be able to cover the way we want to. Okay, so and we want to don't create a huge gap between the weekends. So it is little fast paced, but it's intended for doing that, by the way. Okay. Okay. Seems like no one has any questions so far, so we'll go to big data introduction. How many of you know what is big data is, or the big data technology? How many of you have exposure to big data technology? When I say big data technology, like typical Hadoop technologies, which is like HDFS, MapReduce, and all that. You can put yes or no on the chat page. Okay. HDFS, MapReduce, Spark, Hive, right? These are the 4 things. Okay, let's see. There are a lot of charts. I have not looked at it anyway. Okay, a little. Okay. Yeah. Okay. Anyone else has any exposure to big data? Okay. Okay, Siddhant worked a little. Okay. All right. Not a whole lot. Okay, that's what I get. Okay. But you have heard about it, right? Anyone hasn't heard about it? What big data is? Hadoop technology, Cloudera, Mapper, this, that, or it's completely new subject for most of you. I mean, at least you know what it is, right? Hadoop, most of you. Yes, no. Either sleepy. Okay. Okay. All right. Just want to know what's your guys' background. Okay, good. All right, that's fine. So let's start it. Okay. I'll bring up one of the slides here, right? I'll give you all these slides in a email, or I'll ask you guys to download from my Google Drive. I'm assuming all of you have been working. Some of you have been working many years in the industry, right? And some are new, I know, who have just started their career in the this year, last year, or a few years back. But people those have been in the industry for last 10, 20 years, they probably understand how the industry has moved over the time, right? How the industry has moved over the time in terms of one of the things is data growth, right? You see here in this picture, right? One of the major what you call motivation or reason behind the technology changes or the platform changes is the data growth. You see here 2008 kind of 1 to 2 zettabytes. This is the unit of at the bottom you see zettabyte. Zettabyte means there are 21 zeros on the right side of 1. Okay, 21 zeros. Like 6 zeros is for 1 megabyte, right? 9 zeros for 1 gigabyte, right? Similarly, like 12 is 1 terabyte. So 21 zeros is 1 zettabyte. Okay, you can have that calculation, right? But you see over the last 20 years, right? 2000 or 10 years, 2008, although we are in 2020 right now. So we are reaching 45 zettabyte of data. That's the total world data volume in the whole world. Okay. And if I don't have the projection for the next forecast for the next 5 years, you can look at Google and find out some, right? But you could pretty much see the growth is pretty exponential. Look at the angle of this, it's more than 45 degrees. What does that mean? That means the data is growing or data is doubling almost every 2 years. World's data volume is doubling every 2 years. Even that's been, maybe even less than 2 years. Right? So that is one of the major challenges for the industries, right? So what is the major challenge? So one of the things, as I say, so motivation. So motivation is data growth or region, I would say, or challenge, whatever we can, right? So data growth, which is happening exponentially, and data is doubling every 2 years. Okay, that's one. So what does that, when your data is growing at this fast pace, what's the main challenges with that, right? Storage, right? Of course, where do we store them? And once you store it, the immediate next problem comes is how do I process it? Right? So these are two major challenges, I would say, from data growth, data storage and data processing. So just the data growth is not the only reason for data for the platform change or the big data we are talking about. There are other challenges as well. You might have heard about something called 3V, as you see here, right? Volume, velocity, and variety. Volume is just what we talked about, data growth. But how is it growing? What's the nature of this growth? That's where comes these two elements. The velocity. Data is growing, or it's coming to your enterprise storage much faster, right? If you have been working in data warehouse area, ETL area in the last 20 years, right? When I was working, in 2000, 2001 as ETL engineer, in fact, in Dallas, that time, our batch process was once a month, once a week. We are running this retail company. We are loading the data once a week. Every Saturday and Sunday night, we load the data. Monday morning, it's available to our reporting people, which they are using business object that time. It's once a week, right? And over the year, probably they might have not seen. I have left that company long back, but the data, the speed at which the data is arriving at your what you call ecosystem, or I would say data center, it's changing, right? If it is batch once a month, once a week, it's becoming once a day or once few hours. Not only that, a lot of this, the quality type of ingestion is also changing from batch to near real time, right? So those are the measures, so which is called velocity or the frequency, right? So one of the thing is called real time, right? As I talked about. What are the major use cases? Can anyone talk about what are the most real time use cases you see in the industry or in wherever you work? Anyone? What are the real time streaming use cases? You guys do Netflix streaming, you guys do all that stuff you do, right? Any example you guys can give? Anyone? What's the real
Surveillance cameras.
What is it?
Surveillance cameras for monitoring traffic.
Yeah. Cameras, traffic control, real-time traffic control, of course. And some of the real-life use cases or real-time use cases, right? Of course, I can talk about some of the very common ones. You might have heard about it, right? Monitoring industrial machines, of course, right? I would say industrial IoT. It's called IoT. Industrial IoT is in Internet of Things. I can talk about that way, or just standard, industrial manufacturing. If you are manufacturing something in real time, you want to control the quality of your products. Typical subfloor. I used to be mechanical engineer earlier. What is subfloor, right? So to control the quality of your products, you may want to monitor it in real time so that you can change your what you call how are you producing it, right? But industrial IoT is one of the major thing coming. It's already there. You might have heard about Internet of Things, right? Internet of Things, where every devices, there are many devices will be connected to the internet. Right? Whether it's your fridge, a refrigerator in your house, or your sprinkler system, or your garbage, dumpster outside, everything probably could eventually be connected to internet. Same thing with an industrial IoT, right? All your different devices within the industry, within the product, within the industry they are being used, could eventually be connected to internet, so that things can collect the data as it is producing, right? So thing like look like smart meter, the energy meters that you is put in your house, right, which is measuring the energy consumption within your house in real time and feed that data to the power grid, so that the power grid will know exactly how much consumption is happening by region, by house and all that, right? They can monitor how much energy or how much power they need to dump into the power grid, right? In real time they can control it. Smart meters, we did a project for what do you call Los Angeles. I did a few years back. We are building this smart meter where they they will be used for real-time monitoring of the energy consumption by every house, right? That way they can take better control, better decisions, better control on their cost and all that, right? These are some of the other things, fraud detection and all that. I probably already know that. Very typical use cases, right? Suppose you are charging a credit card, and is your credit card or somebody has stolen your credit card and making a charge somewhere. Is this charge a fraud or not, right? Whether it's online or in the real credit card, right? Is it a fraud or not? If you don't detect in real time, your money will be gone. Of course, bank has to pay it, but basically banks are losing billions of dollars every year on fraud detection. But if can be detected on the fly in real time, it can be blocked from getting stolen. That's why you get in your text in your most of you probably have got mobile. Hey, there is an verified charge on your account. Do you approve it? You say no or something. That means immediately they will call you. They make sure it's a fraud, or right. All of us have probably experienced that kind of thing, right? So fraud detection has to happen in real time so that it can be protected. Your credit cards could be protected, right? There are many other real life industry use cases. One is called real time campaigning. Okay, most of the companies who are in retail business, right, even wholesale, doesn't matter, retail in the sense when they're consumer focused companies, right, whether it's a retail as in Walmart, Kroger, all that, or even pharmacy company like CVS, right? When the people are on the what do you call they are in your on your website, right, and they are trying to do something, like they're moving from one product to other product, or navigating in your website for buying something, whether it's Walmart, whether it's Amazon, and all that, right? You look at their behavior, and looking at their behavior, you can recommend the products that they want, right? Real time recommendation, real time campaigning, real time recommendation, product recommendation, right? So you recommend the right product to them in real time, so that they will be able to buy it or be able to take the decision at that moment, right? If you, like they say, consumers have very little attention span. If you do not, if somebody is looking for a laptop, right, on the Amazon or somewhere, right, if you do not give him the right option, the recommendation right away, he may go somewhere else and buy, get his business done somewhere else, right? So unless you track the customer behavior in real time, build products, build your AI, ML, whatever engine you want to build, recommendation engine, which you call, right? You will not be able to serve your customer in real time, right? In this world, in this age, when people are in mobile device and all that, right, decision can be taken right away, right? So real time campaigning, real time product recommendations, those are extremely key in a world where everybody is connected to every other, right, in real time, right? So those are some of the real time use cases I can think about. Okay, so as I talked about, right, so velocity is very key. The data is coming in real time. Are you able to process it in real time? Those are the other pain points. Then the variety, right? The variety is in many different formats. It could be structured as in tabular format. We must all of you have worked with database tables like customer file, your sales file. Those are all structured. But how about semi-structured like JSON file, XML file, right? So that's also a challenge, right? Variety. So typical tabular format and semi-structured like XML or JSON, you must have all know what are these file formats I'm talking about. And third is unstructured, completely text, free form text. Okay, so free form text. How do you know if it's things like you are chatting over your mobile device, your WhatsApp, and all those things going on, right? Those are all free text. Can I do sentiment analysis based on this in real time, based on the text people are writing to each other, right? Or the comments people, the feedbacks people have given in batch, but I want to study, look at it, bring out the insight from the text, right? I can bring out the insight from the text, like I want to look at what are they talking about, right? What is the topic they're discussing? What's the theme of the topic they're discussing, right? What's the intent inside the text, right? And there could be also compliance reasons. If a call center guy is chatting with a customer, they need to be within the boundary of the compliance. They cannot just talk anything. I was working for Toyota Financial a few years back. The reason they are doing text analysis was because they say we need to make sure all this text data we are collecting is within their compliant, right? You could get sued for many reasons, right? Here law is very strict, right? So is it compliant? So there are many reasons, right? You need to see what are the topics they're discussing, what is the theme, what is the intent, and what are there are many things. NLP is one of my core subjects. We have built products on NLP, which are NER, named entity recognition. I have used a lot of deep learning algorithms to do that. But anyway, but there are a lot of things can be done on NLP, by the way, natural language processing. Okay, it's a huge topic. I don't want to get into that, but there are tons of stuff you can do. And nowadays, people are looking at your emails. They're looking at all the documents. Every company has, where the, or what you call back and forth discussion between customer and the business, right? And they want to store it, analyze it, bring out the insight. But I'm doing a project in my company right now, not in my company, in the company I work, which is just to give you idea, right? What we are doing. We are looking at some of the I'm just thinking, should I tell it or not? Maybe it's not compliant. Okay. But anyway, we are doing some NLP analysis of some of the patient data, and we are trying to find out, based on the analysis, we are able to see, hey, should this medical operation should be approved or not? Think of typical insurance approval or not. So this is one thing we have been doing. We are doing this with the NLP engineer. I think I'm doing it and leading it for last 6 months. So a couple of engineers are working on that, but just to give you an example. Okay. But anyway, so as you see, the bottom line is volume, variety, and velocity are the three major regions for data growth, and that's what is fueling a platform change, right? That is fueling a platform requirement for platform change. Why? For platforms, how we used to store, how we used to process is not relevant anymore. I won't say relevant. That's not a right answer, right comment. I would say those are not sufficient to handle the requirement of today, right? I have been working with relational database in 90s. We started with DBMS like Oracle, SQL Server. Many of them who have in Windows industry probably have worked with it, right? In the 90s, were very, very popular. Okay, Oracle, SQL Server, there is Informix, many of them, right? All these different typical database platforms, right? Then what happened towards the end of 2000, 2001, 2002, around that time, right? So these are all great platforms. I don't have anything against them. They're great platforms. They're good for what you call transactional processing, or we call OLTP, online transaction processing platforms. They're very good with that. When it's online transaction processing, what kind of thing? Like order entry. I want to build a order entry system. ERP systems, most of the ERP systems, CRM, supply chain, all that stuff were built on platforms like this, because they can do insert, update, delete, this kind of stuff, right? They're very good at that. Right? Now, then what happened? Then towards the end of around 2000, 2001, right? A lot of data warehouse applications started, or analytics. Okay. And when those kind of applications started, because as you are collecting the data over the years, 3 years, 4 years, 7 years, 10 years, you need to analyze it. You need to take business decision support system, DSS, right? Those things came up. And for that, these relational databases were not good enough. Yes, we did it, but it was not good enough to do the kind of work we need, because the use case is completely different. Here I'm doing transactional processing. Here I'm doing analytical processing. Here I'm looking at single records. Here I'm looking at historical records. Here I'm looking 1 record, 2 records, 10 records. Here I'm looking millions, billions of records. The use case is different. The workload is different. How you process it is completely different way you are doing, right? So here then came the new wave of technologies called MPP architecture, MPP platforms. MPP stands for massively parallel processing. Okay, it's called massive. Okay, it's a massive parallel processing platform. What are the technologies came? What are the different companies came that time? You might have heard about Teradata, right? Teradata is one of them. They're still there, expensive, but they were very effective platform for doing massively parallel processing. Take your 7 years of worth of sales data, billions of record, process it, run it, build report, in matter of hours, rather than doing, slow, something running very slow in Oracle or SQL Server. These are built for this kind of applications. Okay, you might have know some other technology like Natija. You might have heard about Vertica. You might have heard about many other technologies. I will not go too much, there's several technologies came in those period. Okay, Natija. One time I was my expertise was 2000 in 2006, 2007. I was my expertise was in Natija. I built starting 2006 all the way to 2012. I did at least 7 to 8 or 10 migrations from DB to Natija, Teradata to Natija migration. I do with the business with Bank of America, American Express, many different companies. I did at least 10 migrations. I did. Okay, that was very hard that time. So Natija, I was anyway. So those are very hard. Time when these technologies were lot of data migration happening from traditional legacy platform, like from here to this platform, Natija, Vertica, all those stuff, right? But then this is like these are like 1990s. Then these ones was happening like 2001 till 2010, 12, something like that. Okay. Then what happened? Then once we around 2012, 2013, right? Then this whole Hadoop technology came. Okay, all Hadoop technologies came, and they say, hey, whatever you are doing here in Natija, Vertica, and all that, we can do it in a open source technology which is called Hadoop. You don't have to buy these expensive platforms, and still has limitations. These used to be called appliances. They used to typically we call those appliances, data warehouse appliances. Okay, DW appliances. say, hey, we have better technology now, open source, which is coming from Google, Yahoo, all that stuff, and you can use it, and it's much cheaper, and it can scale as much as you want, right? It can scale as much as you want. You are not restricted by anything here. That's great, right? So then the whole wave of migration started happening from Teradata to Hadoop, from Netezza to Hadoop, from all the Oracle to Hadoop. It just went on from 2012 all the way. It's happening till now. Okay, till now or till last year it was lab. I don't think much happening. Yes, we even in my CBSO we are still doing it. Every day I'm actually doing it. But anyway, but what I'm saying, so this is where some technologies came. Apache Hadoop, as I said, and this is where we are talking about the Hive, Spark, HDFS, all this technology, right? HDFS, MapReduce, Spark, Hive, right? These are all open source technologies, completely free. I won't say completely free, but these are, if you can want to, you can download and start putting it yourself. Right? And some of the technology vendor companies which excelled in those are called, you might have heard about that, Cloudera, Hortonworks, Mapper. Okay. So in fact, I worked on all technology. Mapper, I worked in American Express, other companies. Hortonworks, I'm working in CVS. Cloudera, I have worked. Okay, where is it? Okay, somewhere. At least, but I have trained most of the students in Cloudera, by the way. Okay, so they're all the same with very little variances, and it's pretty much they all use the Apache Hadoop technology, right, which is open source Apache community. They built it, and they were, these companies became very popular. Last year or year before, Cloudera bought Hortonworks. But I'm just saying, hey, what happened after that? We are in 2018, 19, right? Around that time, what happened? 27, 20. I'm just giving that time around, which where we are right now. What is happening? Then the whole cloud thing came up. Cloud has been there some time, but the critical mass started happening around this time. People, the heavy adoption in this area started happening 2015, 2016, 2017, right? It's all started, I would say, in starting 2015, I would say, right? So they say, you know what? We have a better technology called cloud. Whatever you are putting in your on-premise platform, whether it's a Hadoop 100 node, 1000 node. When I was in American Express in 2012, 2013, American Express used to have 900 node mapper cluster. Later on, they probably grew 2000. I don't know how much they have. I've worked with, I was with a consulting company, of course, MNC. So we are working with many companies, starting with Apple, United Health, Travel, what do you call Travelers, many companies, right? What is Databricks all about? I will talk about that. So all these, companies I have been working with, so they are all using all this technology, right? Which has nothing but Apache Hadoop technology, which is the major technology. We will look at it today and this week. But then by 2016, 2017, 2018, like the cloud adoption became more and more popular. And with that, like things like Amazon, AWS Cloud, then you came your Azure, right? And then the GCP, these are the major players, Google Cloud, they all came in. They say, hey, you don't have to have your own servers, maintain it, patch it, all that. You don't need to do that. We have it, everything on a cloud. You just load your data, put your stuff and forget it. We'll take care of everything, right? We'll take care of everything. You don't need to have, you want to have a big data solution? Don't buy 1,000 node, maintain it, all that stuff. It's a lot of hassle. Just come to our platform, AWS, spin off a EMR cluster in 10 minutes. You are there. Typical Hadoop provisioning of few nodes takes 6 months. 6 months. I was the one provisioning in my project in CBS last year when we started a project. I provisioned close to 69 nodes, Hadoop nodes cluster. The timeline was like almost 6 months. We started 2019. We started the planning around to the October of 2019. Then they said, okay, that the capacity planning happened, is that, okay, how many nodes we need, total, I think 69, close to a, I don't know, $1 million, $2 million, so that kind of something like that. So each node for every month we have to pay $1,700, just to give some numbers. So we have, did some calculations, all that. So right, so every year we have to pay, I think, $1.some million. But anyway, on this specific project, and they say, hey, but by the time you write your PO, purchase order, till the time it comes back into your data center will be minimum 3 months. Luckily, they had some spare notes. They gave it, hey, you start using this, and when you come bring it, you can. So luckily, we didn't have to wait. But that's a typical time. Since we had already 2,000 node cluster, we just used whatever was available. Then finally, we repurpose it for something else. But anyway, so that's the typical. But here, it's to set it up and make it ready. It's just too many hassles. Too many hassles. I mean, I'm still. Just because I'm talking about hassles. Last week we had some issues with performance, this, that, some queue not running, that, right? And I don't have to worry about all that. I just spin off my EMR cluster here. In 5 minutes, I can spin up 10 node EMR cluster. In 5 minutes, it'll ready. I don't have to wait for 6 months and put my data, start working on it. So that's a big, huge attraction. Yes, there is money to be paid, but I don't have to wait for these many months. I don't have to worry about the maintenance, patching, version, all that stuff. AWS will take care of it. These are all completely fully managed services, fully managed, right? Vijay will cover all those stuff. What is SaaS model? What is platform? What do you call infrastructure as a service, platform as a service, software as a service, differences and all that. But I'm just telling. We will go over all the details of AWS. I'm not going into the AWS platform details at this point. I'm just giving you the example. Okay. So cloud came up. It completely changed the paradigm how we store and process the data. Basic premises here: storage and compute are independent of each other, completely independent of each other. I can have a storage somewhere and I can have compute. How much compute I need? It would be a completely different service altogether. You understand the storage and compute. When I have a laptop, it has some storage, it has some compute power. It has so much of memory, so much of CPU, all that, right? That's how when you buy a laptop, you are getting storage and compute both together. I can say, hey, I'll just give me the storage, I don't need compute. Or give me the compute, I don't need storage. It has to come together. But how do I keep both separate? Right? This is how cloud works. I can have my 1 terabyte data on my laptop, but I want to have 100 gigabyte of memory, and I want it on the fly. I can on demand. I can use it. Is it possible? No. On the laptop we cannot do that. Whatever you have, 16 GB memory, RAM, whatever you have, right? Unless you add something on your in your laptop. But that's the difference. Here I can use any computer I need with my storage. So compute and storage are completely two separate services, and I can choose what I want to wear. Okay. Of course, you are paying for it. It's not, nothing is free here. You are paying for the services, but you don't own it. You terminate it, it's gone, but your work is done too, right? Anyway, so when that came, all this technology we talked about, cloud or Hortonworks Mapper, they lost theirs because many companies started moving away from this on-premise platform, right? On-premise to cloud. Lot of migrations happen. They moved away from the on-premise platform to cloud. It's happening every day, every week. Some company is going to cloud. Currently, I'm working on one of the project last 2 months. Our goal is to move this one of the product to GCP, Google Cloud, which I'm working on right now by 2021. We're working almost every day with Google people, almost every day. Meetings with them. Right? So cloud migration. Last couple of years back, we moved one of the analytics AI application to Azure, on the retail side of CVS. Okay. So yeah, so this is happening every day. This is where the demand is growing exponentially. Finding right data engineers who knows this technology well, who knows how to, ingest the data, process it, make it ready for business consumption. That's where the major push is, and I don't think it's going to slow down anytime soon. Okay, next 10 years you can pretty much expect this technology cloud with data engineer, data architects. I mean, it's a huge exponential need, and cloud is not going away. Whether it's data warehouse, whether it's online transaction processing, real-time streaming, reporting, AI, machine learning, anything you want. Standard web servers on that. Uh, so you already know, right? Your service now is on cloud, your Salesforce is on cloud, your traditional even ERP platforms are also going on cloud, right? So if your traditional platforms are going cloud, so I mean 5 years from now, 90% of the, say by 2020, 50% of the world's data will be on cloud. So your future in IT is completely tied up with cloud. Pretty much. I mean, if Amazon is spending billions investing, and if wherever the big guys are going, you just have to ride the wave, right? You are too small to chart our what you call future without tagging to some big guy, right? So anyway, so that's what is happening. So because of that, we are learning cloud. Okay. So computer. So this is what happened in the last few years. That's the reason Cloudera stock value went down to $5. I don't know what is today. They were completely decimated. These products were completely decimated in their value, market value, because of these guys. Nobody cares about them anymore because nobody wants to build in on-premise anymore. Everybody wants to go to cloud. Who cares about the cloud? And they are trying to survive, doing something, some cloud version, this, that, right? But anyway, so that's the story. So it started with relational, now here it's all about cloud. Of course, this company have invested billions of dollars in setting up regions all over the world, setting up networking all over the world with their data centers connected through dedicated pipelines, network pipelines with even underwater connections with submarine networking, like Microsoft does. I was in one of their conferences a few years back in Seattle. They said, we are not a software company anymore. We own networking, we own submarines, we own like everything, right? So that's where the industry is going. Okay. That's the huge change in the platform. Okay. Questions so far? So this kind of your it's a background to give why we are studying big data or cloud. I mean, just the pure big data has not much value now. If you just purely stay with the big data, hey, I want to learn big data. Yes, great. But on-premise big data 5 years from now, none will be doing. Everybody will be doing on cloud. There will be some components. I won't say none. There will be some because of the data security issues the people are worried about. But those things, concerns are also going away very quickly. Okay. So that's the reason we are not focusing heavily on big data, every technology. We are focusing on a couple of technologies which we want, these two, which we want in the cloud, which actually is just the Spark. And yes, there are Kafka, all the stuff, all those real times, but there are alternatives on the cloud. We don't need to. Okay. So that being the what you call context or the foundation of why we are learning, right? The next thing is, what do we learn in the big data or the Hadoop ecosystem, right? Introduction to Hadoop. It will be introduction to Hadoop. Then we'll I'm not taking a break today. We'll finish up in another 1.5 hours, so that we can be done for today in the first day and Diwali. So maybe from next week, from tomorrow we'll continue. Okay. Just want to set the context today. That's a lot of, as you see, a lot of storytelling and all that, which may be okay for a lot of people don't have background, but just setting the context for everyone. So introduction to Hadoop. As I said, right, some of the pioneers in this area, we call it Hadoop anyway, Hadoop technology. Again, the motivation, I kind of talked about that, right? Databases, then analytical, that didn't scale up. Now the Hadoop technology came, so right, they couldn't handle. This couldn't handle. Now this came, right? Now they couldn't handle. Now they're going to cloud. But even before cloud came, there was Hadoop. Some of the pioneer companies those who pioneered this thing, these technologies are Google. Google is one of them, right? Google has published 2 papers in 2003 or 2004. Go ahead and look at it. 6 months apart, there are 2 papers. One is called GFS, and other one is the MapReduce. 2 papers produced in those time. Google file system, GFS is Google file system. Okay, Google file system, GFS, and also they produced a paper called MapReduce 6 months apart, February and October and April, something like that. Don't exactly remember the day, month. I think 2003, I believe 2003 October and 2004 April. Okay. So these are the 2 major papers which kind of change the philosophy or change the way we think about storage and processing. Okay. So from GFS, but anyway, by that time, there is one guy. What's his name? Google father of Hadoop. What's his name? Let's who knows what's the name of this guy? So slow.
Which one? Which one? Tikanta, I was not hearing. Which guy? Google.
Yeah, the who no, the person who kind of started this Hadoop, the whole elephant thing you see on the Hadoop, right? What's his name? What's happened to my internet thing? Let's see. Internet is on, right? Yeah. So slow. Okay, let it come back, but in the meantime, I'll come back. What's the name? Okay, here. Father of Hadoop. Oh, not father of Hadoop. This guy, dog cutting. Okay, so this guy is kind of touted as the father of Hadoop. Okay, so I won't say he was a pioneer, but he came up with this concept and name and all that. So, and the elephant symbol you see on the Hadoop is actually his son's toy. He had a elephant toy, and that's how the whole thing came. But this guy was again, this guy was he was working for something called Knots or something. I forgot that he was building some web crawler. Okay, he was building a web crawler software which will crawl the website, the internet of I would say internet of things, but the whole world wide web, and collect the information, right? So the URLs and all that. So so this is how he said, hey, how do I massively, how do I I need a lot of compute for this, right? I want to scale big. So how do I do that? So for that reason, that's where he kind of went with a massively parallel processing framework called Hadoop. Okay, that's how it all started. At least from the Hadoop standpoint, from the Hadoop, and he named it Hadoop and put the symbol elephant symbol for that, right? That's why he called he's called the father of Hadoop. Then he left, then he joined Yahoo after some time. He still lives in the Bay Area, and so as you see, so he can look through his what he's doing and all that stuff. Okay, but from the technology standpoint, Google has major role here to start with. Okay, as I said, the GFS, Google File System, eventually became MapReduce. Okay, so when I'm sorry, not MapReduce, sorry, HDFS. Okay, HDFS. Google file system become Hadoop file system. GFS is Google file system. HDFS is a Hadoop distributed file system. Okay. Okay. So based on this Google file system, Apache open source, right? You know Apache, right? Apache open source, which is built by the open source community, pretty much, right? They went ahead and built this HDFS, which is kind of the scalable storage. If you want to store petabytes of data, here is HDFS. That means there is no limitation. Terabyte, petabyte, you can have it without any issue. Okay, so that's one came up, because that's the see, any platform you want to build, you have to start with storage. So this is a scalable storage platform called HDFS, was built based on GFS, which came from Google. Second thing, as I say, after 6 months, these guys, Google guys, published another paper called MapReduce, which MapReduce is kind of your processing framework. That's great, we can store it, but how to process it, right? And that's where the what you call distributed processing, right? That's a distributed storage, storage, or however you call it. But the other thing which came is distributed processing, and this is where came the MapReduce, based on Google's MapReduce. Again, who came? Apache. Okay, Apache Hadoop came. They built something called MapReduce, which is nothing but Google, which is nothing but your massively parallel processing platform. So with these two, HDFS and MapReduce, your foundation is built, right? If you look at one of these pictures here, right, which is from Hortonworks, by the way. So some of the Hadoop technologies, first thing as you see at the bottom is HDFS right here, Hadoop distributed file system. Then on top of that, you see here is, don't worry about the YAN, all those, but there is MapReduce. Okay, version 2, don't worry about, but this is a distributed file system, distributed processing. These are the two things you need to start any platform. Any data platform needs these two by default. On top of that, you can build your other stuff, but without that, you cannot. Your foundation has to be there, right? So this is the foundation, which is scalable, distributed. Those are the key things. We'll talk about that later. And once those things happen, then you can bring in your application. Okay, I can have my database application. Okay, bring in Hive. I want my ETL, bring in here Pig. I want to bring my machine learning, bring in Mahout. I want to bring my NoSQL, bring in HBase. So all these things then came up on top of this. But these are the two major foundation you need to build a data platform, which is storage and processing. HDFS is storage, MapReduce is processing. Okay. Then just I'm talking in terms of historical growth, how it happened, right? Historically, how things evolved. Then came the Hive. Hive came from Facebook. Sorry, Hive came from Facebook. So Facebook built Hive, then eventually they open sourced it. So it became part of Apache Hadoop. Okay, then it became Apache Hadoop adopted, I would say. Basically, they say, hey, we built it, you take it, you maintain it. It's not our anymore. Just give it up. Okay, you maintain it. So from since then, Apache Hadoop is maintaining Hive. So what is Hive doing? So Hive does all the database stuff. It's great to have storage and processing, but people are used to reporting, people are used to SQL, people are used to database. If you don't provide a database interface to a storage platform, nobody is going to use it. How many people open the file and look at what is what? Right? You can't do that, or you can't just write programs to do it all the time, right? So database, you need the database interface to your data. So this is where Hive comes. It's database on Hadoop. Okay. That means you provided the database, table, SQL, all the stuff that you typically do in your standard database operation. Okay, so this is where comes Hive. You see that Hive query? This is where it comes. Then over the years, right, around 2010, I believe, Then comes something called Peak. Okay, Peak came from Yahoo. Okay, it's very popular during that time, 2012, 2013. It was extremely heavily popular because it one thing it did, it made ETL easy. Rather than writing programs, Java programs in MapReduce, which was very not difficult, but at that time, if you remember, if you are there, people used to need Java programmers for doing MapReduce. 2013, 14, 15, around that time. They used to, the requirement was you need to be Java guy to do map because it was all Java. It was not easy to write and all that, right? So Pig Latin came from Yahoo. They made the ETL easier. You don't need to write Java program. You write few lines of code, and it will internally it will build your Java code behind the scene and process it. You don't have to worry about knowing Java anymore. Pig, very popular. It was the main ETL engine, the creating your data pipelines, what you call data transformation pipeline. If I'm starting with raw data, I have to cleanse it, I have to curate it, I have to transform it. I need a language, I need something. And Pig was very helpful. But behind the scene, Pig was actually doing MapReduce under the hood. So it was actually processing using the MapReduce framework, but you don't have to write it in Java. You can write it in Pig, which is very easy to write. But that also was there for a few years, right? A lot of programming, Hadoop programming happened with Pig and MapReduce for many years. So around 2013, 14, 13, it started 2012 and all that, right? Then came something called Spark. Okay. Spark started from University of Berkeley, UC Berkeley, as a PhD student's PhD work. Okay, and which eventually became one of the popular framework in the industry. By 2014, Spark was the top sub project in the Apache, with that means in largest number of contributors in the community, largest number of downloads. That kind of decides how popular is this product. If a lot of people are downloading, that product is hot, right? If a lot of contributors are there in the Apache community, that means this product is hot. By 2014, Apache Spark reached that stage. I'm sorry, Spark reached that stage. And yes, it came from University of Berkeley, but eventually it was become open source. So now Apache is maintaining it. Okay, so Spark became part of your Hadoop ecosystem. But you see here, Spark is not there. By 2014, it became part of your ecosystem. Okay, it became part of your ecosystem, which you see here. We will talk about Spark at some point. So the Spark has its own tech stack. So there are so many things came in Spark. We'll talk about in more detail. But the Spark became the main processing engine on big data, and eventually now it is on Win Cloud. Okay. So that means I can do SQL, Spark SQL, I can do Spark streaming, I can do Spark machine learning, I can do all different kinds of workload, different kind of use case. It can support everything, and it was like in memory. There's a lot of good things came. We'll talk about that. It became in memory. It is distributed. All that good stuff. It's fast, 100 times faster than Hive, right? 10 to 100 times faster, and it's memory heavy, but with memory chip, right? It became one of the major. And along with that, you can do machine learning, building AI ML. You can do that. You can do real-time streaming. You can do Spark streaming. You can do SQL database stuff. You can using Spark SQL. All of them it's supported. That's the reason Spark became very popular. Okay, and that's the reason you see AWS is using AWS Glue, EMR, all that stuff is actually the best coding is done in Python and Spark. Okay, so that's one of the reason you need to be very good at Spark if you want to be a good data engineer. So 2013 till now, so Spark, picked up, and there are many other technologies came. That's not the end of it. You see, there is Uji, there is HBase, Scoop, Flume. Those are some all side technologies. Scoop means something you want to load the data to Hadoop, bring the data from somewhere on database and load it to Hadoop. You need something kind of tool called Scoop. You can learn it in a couple of days, not big deal. Right. There you see here Mahout and all that, which is the machine learning on Hadoop. This was long back, 2013-12. It lost its charm because now everything can be done in Spark. Spark has its own ML, as you see here, right? It has its machine learning. So Speak was not it was not, it didn't pick up that way. It's right. Then you have R connector, forget about that. There is, that means you can do R programming on top of that. I'm not focusing on that. Then something on the right side called HBase. Okay, HBase. So HBase is a NoSQL DB. We'll talk about what is NoSQL, because in AWS you need to learn a technology called DynamoDB, and it is based on the same technology called NoSQL. So there are different types of databases. I have talked about OLTP. I have talked about OLAP. This is OLAP, right? I didn't probably put it here. This is massively parallel processing. This is OLAP. Okay, right? This is OLAP, online analytical processing. So, and this is not OLTP. This is not OLAP. This is something else. Yes, it is OLAP, right? So this is a special kind of technology most of the companies nowadays use for special use cases. We'll cover the use case when we go there. If I have a website, you might have heard about technology like MongoDB, right? You might have heard about MongoDB. You have to, again, HBase I'm talking about, DynamoDB, DB on AWS. So these are some of the technologies which are special work. Suppose I have a website. I want to expose my data very fast, very, what you call extremely high read and good read and good write, right? It is 100 times millisecond response. They're very, very fast. If I want to build a website, I would rather have a database like this on the back end. Okay, although you can have MySQL and all that, but you want to support many users, like Facebook uses HBase, supports billions of users, stores petabytes of data every month. Every month Facebook stores minimum 1 petabyte data on HBase, but it's able to handle. Okay, so that also came. Where did HBase came from? Little bit background. Came from Google's Bigtable. Bigtable was the NoSQL version available in Google. We are doing GCP in my workplace, and they have the Bigtable. Based on the Bigtable concept, HBase was built. That's another white paper, by the way, from Google. Okay, somewhere in, I don't know, 2008 or something it came up. Then based on that, Apache community built HBase. After HBase, there are many other. You might have heard about something called Cassandra. Maybe you have heard about Cassandra, MongoDB, HBase, DynamoDB, CouchDB, Couchbase, MarkLogic. Many of them. What you call NoSQL. There are 150 NoSQL databases in the market. Okay. So don't worry about all those. You may want to just focus on one or two. Okay, so it's like you are collecting all the pieces from here, then you are becoming the kind of everything, when you are building a toolkit, you are looking at all these different options. Okay, that also we'll touch upon, because we have to learn DynamoDB anyway on the AWS, right? So we'll come back to that. So then UGI, don't worry about the UGI and all that. It's like you want to do ETL, you want to do orchestration. You know what is orchestration? Orchestration. You want to schedule some job, right? Once the jobs are built, to do some work, you want to schedule it, right? Scheduling and dependency management, right? This job will run after this job, or this job will run at 10 p.m. in the night, right? Or morning, right? To do that, you need something called orchestration. And for that, how to pass something called UGI. Don't need to learn it, but I just want to tell you, okay? Because on cloud, it has its own orchestration anyway, right? It has its own orchestration, and hold on one second, guys. Getting a text. So if okay, so but on cloud we have different orchestration. We'll talk about that. We'll talk about Apache Airflow. That's one open source orchestration engine came from Airbnb. And we'll talk about the AWS step functions, which is natively available within AWS step function, which will in fact we'll do in our project at the end. How to orchestrate our pipeline, which will build in AWS Glue using step function or Airflow. Okay. So these are the alternatives. We don't need to learn OG. I just want to give you an idea. Then there are many other platforms came. Cassandra came from Facebook. As you see, DynamoDB came from AWS. So a lot of these companies, Airflow came from Airbnb. You know the Kafka. You probably know Kafka. Probably Kafka is one of the major anyway. Real-time streaming came from LinkedIn. So right, all these companies contributed to the whole ecosystem. They didn't keep it to themselves like Google did it. Google didn't give it away, right? They're proprietary. But at least they talked about at least they published the white paper, which helped, right? And which helped. Kafka, LinkedIn, database came from Facebook. Pig and Yarn came from Yahoo. Cassandra came from Facebook, right? So all these different companies build their technologies, gave it away to the Apache community. Said, hey, go ahead, you build it. So now Apache became kind of powerhouse or maintainer of this thing. It's like a trustee. It's like it's maintaining their property and making sure it's all up to date and all that stuff, right? So Apache Hadoop, that's why you call it Apache Hadoop, right? So finally it became Apache Hadoop, which has all these components: HDFS, MapReduce, HDFS for storage, MapReduce for processing, Hive for database, Scoop for loading the data. We have HBase for NoSQL. We have Spark for processing again. You have all that stuff, right? Yes, all these notes will be sending along with the video. That's the goal. At the end of it, you get both of them. Okay. So now it became an ecosystem, Hadoop ecosystem. Apache Hadoop, open, freely available. You download, you can have your Hadoop platform on 10-node cluster without paying a penny. Free. You don't need to buy Oracle. You don't need to buy anything. It's completely open. You can just search on Apache Hadoop, download, and you can. I had built myself in 2014-15 to 3-node cluster myself because I was training that time. I was building my own framework on multi-node cluster that time. I'm not doing that anymore because EMR everything is available. But I can. It's completely free. Right? The VM I will give you. It's completely free. Right? You don't need to. So if you're learning adaptability, learning, you don't need to buy any software to learn it. Right? It's all free. But that's not all. Right? And then all these companies I talked about earlier, Cloudera, Hottenlots, Mapper. They said, okay, great. It's good to have all this Apache Hadoop, what you call distribution, which you call distribution. Well, it's not Apache Hadoop. We'll look at this. These are the distributions, by the way. That means then these companies came up. They started their startup companies in Bay Area many years back. Then say, okay, we'll take this Apache Hadoop, we'll customize it and create our own versions. Okay. They are not writing software here. They took the open source product completely, the whole dump of the code, everything they have written in Java, whatever it is, right? And they created their own version of the platform with platform management software, like Cloudera has Cloudera Manager. Hottenlots has something called Ambari. You see that Ambari? Ambari is nothing but platform management software. Once you have a 10-node cluster, 100-node cluster, somebody needs to manage it. They gave you a UI-based management platform. So it just they just decorated it, made it easy, and on top of that, so they also gave you customer support. You don't want to have a banking company go completely open source. Who will support it? Something goes wrong, you are not going to send an email to Apache community. Hey, my software is not working. It's not. They're not going. Nobody is going to come to help. So you need to go to buy the product somewhere, like someone like Cloudera, so that their support engineers can come and help you fix it, right? So even if it is all open source, as a company, you would rather, unless you are a completely startup, don't have money, that you are okay, go with Apache Hadoop open source, don't have to pay a penny, right? But you are a company, enterprise, big company, Fortune 500 company, I would rather go for a actual company who will come. Yes, I will pay some money. The money you are paying is not for the software, you are paying for the maintenance and the support. Okay, software is free, and that's why you can have licenses with these companies and they can support you. They'll give the support, customer support, patches, this, that, all that stuff, right? So this is where most of the companies in the last several years, they became either Cloudera vendor, or they picked up Cloudera as a vendor, Autonomous as a vendor, Mapper vendor. Mapper went down last year. Somebody bought it. Was it HP or somebody? I think in 95. Their value came so down, 90 or 100 million dollars. Somebody one time they were like billion-dollar companies. Their value, the cloud companies completely. Okay, I think audio came back again, right? So audio was interrupted for a few seconds, looks like. So anyway, right, these companies are trying to survive pretty much. These companies are trying to survive because there's so much onslaught of these cloud companies that they are surviving, right? So that's kind of background of where we are at. Okay, now as I said, then came the say, hey, you don't need to have this thing on premise. We are giving you. Then the AWS came. You know, we can put your Hadoop on cloud. We call it EMR. Okay. Then the Azure came. Microsoft Azure came. Hey, you don't need to put your Hadoop outside anywhere. You don't need to buy the buy the 100 node and build it, maintain it. We have something called HD Insight, which is nothing but Hortonworks on cloud. Then GCP came, Google Cloud. I said, hey, same thing. You want to build your Hadoop on my platform? You don't need to go outside. I can give you right here. And they call it something called Dataprocs, which we are working in my company right now. So now you have big data on cloud. You have there big data. Any cloud you go, you have big data. I don't need to set up outside. So that became very attractive. People say, okay, we don't need to build our own platform. Let's go directly on cloud. We can build a EMR cluster. We can build HD Insight cluster, Datapro cluster. And there are many different choices. To tell you the truth, even we are not going with all this. We are not done. We don't need to go with EMR. There are so many choices. I can put my data on S3, direct, very cheap storage. I can use Apache Glue. I don't need to use EMR. I'm just saying, the choices are many in cloud. Okay, there are many in cloud, so many, and with very little effort, you can learn and build it within days, what will take months in other areas. Kafka, okay, you can have Kafka on cloud. You say, hey, we have something called Kafka managed service there. We have Kinesis, our own service. You don't need to worry about it. They have called Stream Analytics. I forgot what it's called. Azure has. But Dataproc have something called PubSub model. Publisher and subscriber model. SD Insight has similar. I mean, Azure has similar stuff. Okay. So the cloud has all the big data services apart from what they have. Apart from the other services, NoSQL, we have one. You want to do IoT, we have services. You want to do analytics, we have machine learning services. You want to store data, we have a service for that. You want to monitoring, we have it. So anything you think of, it's the services there. At least on AWS. AWS has hundreds of services. Azure has as well. GCP is catching up. It's a distant third, but AWS is number one. Of course, Azure is next. GCP is right catching up. So that's where we are at. Questions so far? History of all these technologies, right? Now, so you see what you call, and you see why cloud is important. As an IT guy, why cloud is critical for your future. If you are IT guy, no matter which area you are a database engineer, report writer, you are a retailer, cloud is a must. Today or tomorrow, your company will go to cloud. It's a must, right? There is no other thing, right? And if you are cloud enabled, you know this, pick with one cloud, understand it, your chance of survival, your chance of making good money in the market, right? It's pretty good. We are see, in my project in GCP, I've been hiring people in GCP in my project in the last few months. We have had 4 or 5 folks. The rates are typically $15-20 higher than. Just give you example. Our GCP architects are $150 an hour. Our GCP engineers are $125 per hour. If I go take normal regular user, regular developers, like $90-100. Standard AWS big data engineers we hired 105. If it's AWS, it goes to 125. If you AWS architect, it's 150. Not AWS, GCP, but it doesn't matter, any cloud. So your rate goes up when you have big data and cloud. Your rate goes another $15-20 up. Okay. So again, looking at the market size, huge. It's a huge, everybody in the world is doing cloud, right? You don't have any limitation. Work from home, work where your platform is anything, anywhere, and you can work on cloud, right? Any place, whether anything you are doing, right? So that is a huge attractive option for most of the IT engineers, right? Work from anywhere, work right any place, and but you build your value in the marketplace, right? That's the key. As I said, I started as a DBA, Oracle DBA in 90s. I became a Netezza expert at one point. I did big data. I have trained big data for life, as I said. Then last 2-3 years, I'm focusing on cloud. Although Vijay has been working longer time. Since I didn't do cloud for many years, I suffered for that. So a few years back, I was. But anyway, I don't tell that. But because I picked up cloud little late. And I did suffer because of that, which I did a mistake. But eventually I thought, no, I have to learn it. So I just eventually had, because there was no time. I didn't have time. Doing so many stuff. But no, I just forced myself to learn last year. So no, I have to do it. So then kind of now, of course, I'm doing it through project in my company, but I have to learn now. So, no matter how, if you are just a non-technical manager, director, you are, you can be out of job so quickly. You will not be able to get a job, let me tell you. Okay, you will not be able to get a job if you are a purely management line and you don't have a technical skill with this, right? You lose your job, it will be very difficult to get back into industry. But if you are technically good, 2-hour point break. I'll finish up in another. Yes, please. Let's take a break of 10 minutes, and then we'll come and go quick HDFS introduction, and then we can close the day for today. Okay, I'll just quickly do HDFS introduction today, and then we can call it a day for today. Okay, let's take a break, and I will stop the recording for now.
This conference will now be recorded.
So we'll continue the discussion. I'll not go too much into technical stuff today. We'll do that. I'll share the VM and practice and all that will probably happen during the weekdays. Maybe we don't, or so we'll see. Okay. So what I was talking about, right now that you understand the what you call background, the history of all this technology, how it all evolved over the last 20-30 years, and where we are at, right? As I said, relational databases, in 90s, data warehouse and appliances in the early 2000, then the big data, right, in the early 2010, and right now we are in the cloud age, right? So this is how the evolution has happened over the years, and that's what we are talking about. Why we are learning cloud and big data, right? Again, as I said, it doesn't have to be big data. Anything you do, cloud is not just limited to big data. We are focusing on big data because there are a lot of use cases are big data specific. That's why we're focusing. You can do it. You can just regular stuff. You're hosting websites. You can do that. You can have standard writing some services, microservices using whether it is Kubernetes, this, that, all those things also you can do. Those services are there as well. But we are focused more on the data engineering side, more in managing the data. This is again me and Vijay. This is our core skill sets and the work we have done. And that's why we're focusing more on this. And we see there is a lot of demand in this area. It's not like it's not demand. There is no demand on the other side of the cloud. Yes, it is there, but we are focusing more on the cloud side, or cloud big data engineering side of it, right? Okay. So with that, right, I was talking about the one of the what you call Apache Hadoop ecosystem. So one of the thing comes into mind, or one of the thing the first product comes into HDFS, right? These are the things I'm touching upon for the reason that you need to, before I get down or jump to the Spark, I just need to give you some background. I cannot directly jump. That's the reason I'm giving this teaching these technologies. But on cloud, AWS, you don't really need to know HDFS. Okay, so you don't really need to. But for me to show it, I have to go through that a little bit anyway. So these are two technology I have to teach you anyway. Today, tomorrow, again, map reduce. Okay. So again, just to bring you up to speed, what are these technologies, right? So that we can focus on Spark primarily in the week, through this week, and Saturday, Sunday next week. I think by the time we get to Saturday, Sunday next week, we'll be doing a lot of deep dive in Spark, okay, and Python and Spark. And we'll touch upon a little bit of Hive. I'm not going to go very deep in Hive because we don't need Hive a lot or at all on cloud. Okay, I don't need it, but it will at least help you if you're just applying for just pure big data jobs, right? But why would you do that? But yes, you can do that, but you would rather become an AWS engineer, right? Why to become just regular big data engineer anyway, right? But again, so anyway, okay. So let's talk about HDFS. Okay. So this is our goal to learn this technology. Okay. And there will be covering some Kafka and all that a little bit, but in terms of when we get to Kinesis and all that, but real time thing we will talk about that later. Okay. So start with the HDFS. What does HDFS stand for? Hadoop Distributed File System. Okay. So Hadoop Distributed File System. Okay. So I have probably one. Let's see. I might have some student material. Okay, I have some HDFS. I'll go over it very quickly. HDFS. Open it. Okay. So okay. So what is HDFS again? HDFS is, right, as you see, it's a distributed fault tolerant file system. You see that, right? HDFS is a distributed fault tolerant file system, right? It says distributed. What do you mean of distributed? Are you saying that my file is not distributed on my laptop? It's kind of, it is not, right? It's not truly distributed. Is it fault tolerant? My laptop files? No. If I storage crashes right now, I will, it will not perform. I just, the whole class will basically, I'll stop working right away, right? If I have to add 1 more terabytes to this my laptop right away, can I add it? Probably not, unless I buy another external storage or something. I cannot do that, right? So, or if I have an Oracle server where I have 1 terabyte of data, and if I have not been working with Oracle since 2010. I don't know what Oracle developments has happened in the meantime. I have not, anymore. A lot of things have changed, but a lot of these traditional platforms, traditional databases are not truly distributed to the, to the extent that Hadoop and cloud can do. There are some distributed platforms. So they can be distributed into the extent they have racks, they have partitioning, all that stuff, right? But they are not truly distributed the way cloud and big data can become. When I say truly distributed, what do you mean, right? For example, any laptop or any platform, right? What kind of scalability you can have, right? You can have horizontal, or I can say vertical scalability. By the way, these kind of questions will come your AWS certification. You learn that there anyway. I'm just talking about vertical scalability and horizontal. There are some questions come in this. So there is something called vertical scalability. There is a horizontal scalability. What is vertical scalability? Most of the traditional platforms are vertically scalable. Okay, traditional platform are vertical scalable to some extent, not even infinitely. Okay, there is nothing infinitely here, but not that scalable. So vertical scalability. What does that mean? Suppose in my laptop I want to increase my memory, right, or increase my storage, I can buy external storage, right? I can buy external storage. So in my laptop, right? If I laptop I want to increase my storage, I can buy one, right? External storage and increase it. If I want to increase my memory, I have 16 GB. I want to add one more 16 GB. I can do that, right? RAM I can increase that, right? CPU processing power, probably not. For that, I have to completely probably replace my what do you call replace my whole what do you call that in underneath you have that, right? So I'm not going to replace my memory chip and not memory chip, the whole chip thing, right? I'm not going to do that. So this is called vertical scalability. That means I can extend my capacity to some extent, but beyond that it is not possible. So vertical scalability problem is or issue is these are scalability is limited, right? I can go to some extent. Beyond that you can't. What do you do after 2 years when your laptops become so old? You can your space is full, my things are not running slow. You just go and buy another laptop, right? That's what you do. So you just buy one more laptop and this laptop goes away, give it to somebody, right? So that's your solution. That's what happens in the industry as well. Your Oracle platform is becoming kind of I would say redundant, but your capacity is coming to 90-100%, and better platforms are coming in. You just get rid of it sometimes at some point. Once you reach your vertical scalability limits, you buy a new platform, pay another $2 million, $3 million, then get to the new platform, right? That's the solution people have been using over the years. Now, what is horizontal scalability? Horizontal scalability, as the name says, it can scale horizontally. Okay, vertical is going up, up. Horizontal is going along, going horizontally, right? And that means, can I add one more laptop if I have to? My storage need is going up. Can I add one more laptop to this laptop so that I have two laptops behind the scene? But for a user like me, it looks like one laptop. Can I do that? Not at this point, but with Hadoop, I will be able to do that. That means many servers connected to one platform called something you call as cluster. Okay, so you created something called you connect many servers, in our case laptop, many servers into one platform or ecosystem, whatever we call it a cluster. So that's called cluster, right? Hadoop cluster, cloud cluster, or big data cluster, Cassandra cluster. You will be hearing that a lot, right? So cluster will become, it's nothing like cluster is a set of nodes or servers, nothing but computers. Okay, there's a set of nodes, set of servers. That's your cluster. There is not one laptop, there is not one server, there are many of them connected together with a network and acting like a single machine. Okay, so it's a set of nodes, set of servers connected over the network, but acting like a single machine. It's like a cluster. Okay, the good thing about this cluster is it can scale in and scale out. Okay, when you say scale in and scale out, I need to add more. I need more storage. All I need to is add more nodes to this cluster. You see here, So here is my now. You see this. I would say some of the figures are here. As you see this picture, this is one of the Hadoop cluster, right? You see there are these nodes. We call it. Forget of the names. There is something called name node here. It's one of the node here on one of the servers, and there are 5 nodes underneath. 1, 2, 3, 4, 5. Total 6 nodes. So together it's a cluster. Okay, it's a Hadoop cluster, or right, and so they are all connected over the network, and they can talk to each other. If I'm log in, I don't care how many nodes are behind the scene. It looks like, to me, it looks like a single server. Okay. When I log in to this server, to this ecosystem, to this cluster, it's, for me, it is like a single server. But behind the scene, it could have 1, 10, 100,000, 10,000 nodes connected. Okay. So there are huge clusters around the world for companies like Facebook and Yahoo. They have 10,000 node cluster, 40,000 node cluster. Huge clusters are there. Okay. So as you see here, there is no limit. There is no physical limit to how big they can become, as long as you can manage it, you know, in your network and physical, right? Yeah, right. So you can do that. So that's where the HDFS comes in, right? But anyway, so scale in, scale out. You can scale in and scale out in terms of storage. As my data needs goes up, I can add 2 more nodes here, or 10 nodes here. So that from 5 to it becomes 10, 10 to 15. As a user, I don't notice that. They can attach it behind the scene. The platform, the framework will allow you, or allow me to do that, to scale in or scale out. I don't need it. I will cut down. Of course, those are easier in doing cloud. When you become cloud engineers, you can create automation scripts that during the peak time, your EMR cluster will go to 10 node to process something. When you don't need it, then 5 of them will automatically get terminated. You can set min and max limits, and it will add, if your CPU capacity goes up to 80%, it will automatically add 1 node. When your CPU capacity goes down to 60, it will get rid of 1 node. So automated scale in and scale out can be controlled by scripting or by services provided by the AWS. It will you can completely automate it. So those are things called scale in and scale out. Okay. So those are much easier to in cloud, on platform, on-prem. They are not. That's the beauty about cloud. You can automate completely. If I already bought 10 in on-premise, why do I have to cut down? Let it run anyway, right? I paid for it anyway, right? So, but in cloud, if I'm not running, I'm not paying for it. So there is advantage there, monetary advantage, right? Because if I'm not using it, if I don't need it, why to run it? Just cut it down, take it out. That way I'll pay less. Okay. So scale in, scale out, and we are talking here not scale in, scale out for everything, but we are talking about scale in, scale out in terms of storage, scale in and scale out. Okay. And this is where the file system comes, HDFS file system comes, which will scale in and scale out, or scale out, I would say. Let's scale out at this point based on your need. Okay. So I can go from 1 terabyte to 1 petabyte, right? If my need grows from 1 to 1 petabyte, I can keep on adding more and more nodes without sacrificing anything. Ideally, I'm saying, ideally without sacrificing anything, you can do that, which is not possible in typical traditional platform. You have to replace it. Here, you don't have to replace it. You just keep adding it. That's the big difference. You repurpose it. You just keep on adding. How is it possible then? It's possible because of the Hadoop distributed file system. Just adding a node doesn't make any difference. I can add to my laptop another connect. Will that solve my problem? I put a 1 terabyte file. Will it make it distributed? No. There has to be a framework. So HDFS is a framework. Okay, it will make that distribute. So it will distribute your file to smaller segments. We call it data block. Okay, We'll talk about those concepts. It will distribute your file on your nodes, servers, so-called servers, many servers, 5, 10, 20, 100, doesn't matter. Okay, to distribute it, and you will not know it where it is going, but it will create the data blocks behind the scene. Okay, it will create the data blocks behind the scene and distribute it in your nodes. Okay, and on top of the, what else it will do? It will make sure it is fault tolerant. If any of the server here goes down for whatever reason, crashes, you will not lose your data. Okay, you will not lose your data using many different technology or many different concepts behind the scene, which we call it replication, and is one of the things, right, which is used as part of the framework to make it fault tolerant. And there are many, what other advantages it gives? It distributes a file. As how big your file doesn't matter. It will take the whole file, break it down into small parts. We call it data blocks, and distribute among the different nodes. But when you look at the file, it looks like a single file. That's the big difference. It breaks it down into many parts. But when you look at it, it looks like a single file. By doing this, you literally solved your problem of scalability. Now I don't have any limit how many files I can put it, how big a file I can put it, because it can distribute 10 parts, 100 parts, 1,000 parts, I don't care how. But if for me it is a single file, that's all matters, right? So that's a big thing which was not there earlier. So HDFS framework is capable of, or it's doing that. When I copy a file from my local file system to a HDFS file system, the framework will take your file. Okay, as you see here, it will take your file and it will break it down. As you see, hey, here is the file. I put it in here, right? The file gets, if file is 1 terabyte or whatever, right? It will break it down in many parts. File 1, file 2, file 3, file 4, file 5, 6 parts. Let's say 6 parts. Let's see. I'm just for example. And for the user, it will look at like a single file, but behind the scene, under the hood, there are 6 parts, and each of these part of is called, these chunks is called data block. Okay. And the typical size of this data blocks could be 64 MB, 128 MB, 256 MB. So data block size, this data block size, right, which is the chunk, could be 64 meg, 128 meg, 256 meg, as you said, double, right? So one of these things you can use as part of your what you call the data block size, right? You can configure it, and there are many ways to configure. There are config files, all those stuff. But this is what the suppose, for example, you have your data block size 64. I put a file with 64 or 65 meg file. How many data blocks it will create? Just one, right? Let's say I create a file of 100 meg file. How many data blocks it will create? 64, then is another. So it will be accommodated within 2 blocks, right? So if I have 1 gigabyte file, right, calculator, right? If you have one gigabyte file, which is 1, 2, 3, 4, 5, 6, 7, and 9, right? So 6 divided by 64, 1, 2, 3, 4, 5, 6. Okay, there are 15 blocks it will create, assuming my data block size is 64. 15 or 16, if you could if you what you call next digit, so it is 16. If you round it, it is 16 data blocks. If I have 1 GB file, it will, behind the scene, it will create 16 data blocks. Okay, it will create 16 data blocks, and it will distribute it among all the servers I have. Suppose I have 5 nodes. Let's see here, 5. So you see the blocks here, data blocks, the small colored ones, squares, they are my data blocks. This is how it will distribute it. 3 here, 3 here, 3 here, 5 here, 2 here. It will distribute it, right? So how to distribute it? How does it do all that stuff is based on some pre-configured algorithm. Intelligently it will distribute. Okay, so you don't have to worry about, but it can be configured. Okay, so the data block is getting, so if you have a file, large file, the inside data, the chunks of data is getting distributed across all my different nodes in the cluster behind the scene, so that it is not at one place anymore, not on one server even. If there are 5 servers connected here, it will distribute in all 5 servers. But when I log in, say, can you give me a count on the number of records in this file? It will give you just as if it is in one file. It takes care of behind the scene, it takes care of all the how to compute in a distributed way, all that stuff is taken care of. Again, that's where the MapReduce comes into picture. Okay, so by storing it in a distributed fashion, by processing in a distributed fashion, you solve 2 problems. I have no limitation in storage, I have no limitation in compute. This even gets better in cloud, because your cloud, your compute is separate from storage. I can have 1 terabyte storage and 16 GB machines for compute, or same 1 terabyte storage, I can go for, you know, better machines, pay high. The choice is yours. Okay. So HDFS framework does few things. Distributed storage, and what do you mean by distributed? Again, it breaks down your thing in smaller chunks, and those small chunks are called data blocks. Typical size of the data block is 64, 120, or 250 MB, and it stores, it distributes in all the different servers that you have in your cluster. Yeah, the question is, can you scale it down? Yes, you can scale it down also. Okay, we'll talk about that a little bit. So fault tolerant, I'll come to that. So fault tolerant, of course, how? So the second thing is, so yes, that looks like great, but what about this node goes away? I lose my power here. What happens? I have 3. You see this data blocks. I have a total 3 plus 3, right? Total 15 blocks. If I lose this data block, what happens? This node, am I going to lose these 3 data blocks? Yes, you are going to lose these 3 data blocks, but how do I make sure I don't lose my data? So for that reason, there is something called replication. For you not to lose all the data, in case of any node failure, I can create copy of that data blocks. Okay, so this is where replication comes into picture. So fault tolerance is achieved by something called replication. What is replication? Replication is nothing but create additional copy of the data blocks. Okay, how many copies? It's your choice. Typically, it is 3 copies. That's every data block has 2 additional copies here somewhere. Is it advisable to keep all the copies in one node? No. Why? If that node goes away, I lose all 3 copies. It is better to put the copies in other nodes. If this node goes away, yes, I have 2 copies here. First node has this blue. If this one goes away, there are 2 other copies in number 4 and number 5. So I'm not actually losing the data. Okay. You're saying you are creating so much copies. If I'm creating 1 terabyte, you are creating 3 terabytes. Is it? Are you saying it is good? I'm paying for so additional, storage and all that. Yes, you are right. You are paying for 2 additional copies, but the storage is cheap, right? Storage is cheap. Okay. But if you go for enterprise storage, go for advanced storage, SAN drives, that all the network drives, which are very costly, right? If you go for those kind of drives, it costs like 100K per terabyte. It could cost this 1 terabyte. If you go for advanced network storages, NAS drives, all those stuff, right? It is very costly. But if you go for So these are the network storage, advanced network storage, which is available in the market, which typically the traditional databases they do, because there is no replication, nothing. They will go for a very good, reliable storage, and they will pay for this money. They will pay for this money. But now, since replication is there, I am not worried about the quality of this thing, because I have a copy. So they can go something called commodity storage. We call it commodity. That means cheaper storage, and there I can pay like $1,000, 1K, to even $500, 1 by terabyte. So you are paying a lot cheaper, right? And there is a trade-off. You are paying less, they can go down quicker, but to protect your data, you have replication. So there is a trade-off between reliability and how much you are paying. But the platform is built based on the notion that it is a distributed, so I don't have to pay a lot for the storage. Keep it cheaper, because my system is built on the premise that, hey, it is by default it is I have replicated copies. I'm not going to lose it. So there will be loss of nodes. Okay, there will be loss of nodes, but my system is built in to protect me from any loss, because I have replicated copies everywhere. But if you do the calculation, even if it is 3 times 1K, $3,000, it's much cheaper than 100K. Okay. Even if through 3 times copy, but still I'm cheaper than going for very advanced ones, right? So I'm better off with this. Okay. So fault tolerant. Other thing is auto balancing. As you are asking the question, can it scale down? Yes. So auto balancing means the framework is capable of balancing the load between all these different nodes. What do you mean by balancing? That means if I'm adding new storage, new nodes to it, the data that is in here will get automatically distributed in other nodes. It's not like these are 80% full, others are staying empty. No, it will automatically rebalance. You see the balancing, it automatically balances. Same thing what you were talking about, Watson, earlier. If I take out one of the nodes, that means you lost the data here, right? In fact, you can manually pull it out, just plug out. As soon as you plug out, right, the framework is intelligent enough to see that I cannot talk to this node anymore. To that respect, let me talk how the communication happens. So the nodes talk to each other using something called technology called heartbeat, HERT, heartbeat, right? You see that heartbeat? They talk to each other, basically checking the status of it. Are you alive? Are you alive? Or this is saying, I'm alive, I'm alive, I'm alive. Every few seconds, whatever the time you set, it's all configured. You don't have to worry about. You are not a system admin here, but just need to know you are not doing this thing yourself. So that means this data node goes down. The name node is the master. Again, let me talk. I didn't talk about the whole architecture. This is a master slave architecture or parent child architecture. There is something called master at the top called name node, and there are few, or there are one or many slave nodes. We call those data nodes. Okay, this is typical Hadoop architecture, by the way. Okay, Hadoop architecture or HDFS architecture. What are the components? Name node. That's the master. And the data node. Those are the slave nodes. And between those, there is communication. And that's done through something called heartbeat. We call it heartbeat. Typical TCP/IP pinging. You ping something, right? It's just like you ping command, PING ping command, right? Same way. This is pinging the other one and making sure it's alive. So constantly checking. Your master is constantly checking if others are all working condition or not. Can I reach out to them or not? If for some reason network is broken, your server is broken, something, you cannot reach it, the name node knows that this data node, one of the data node, whichever I cannot reach, has gone dead. So immediately it takes action, automatically moves. If whatever data loss has happened from here, will rebuild somewhere else. Okay, it will automatically rebuild those data assets or data blocks somewhere else, depending on where the space is available. So this is completely automated. Okay, so that means if you lose something or manually pull it out, it will rebuild because the copies are there, right? So it will try to maintain the same replication factor of 3. Once you lose 3, you lost the some data blocks became 2 now, right? Copy number of copies available 2, so it has to bring it back to 3 again. So it will build it somewhere else, and this process happens automatically. Same thing, if I add more nodes, it will automatically rebalance. That is, take out some of the data from here, put it on the other side. So that is balanced, more balanced from the storage standpoint. Okay. So all that stuff. So the auto balancing, like so dropping nodes or adding nodes. So balancing happens automatically. Okay. So balancing, that's a feature from the framework. You don't have to do anything. Okay. And here's the architecture we talked about: name node and one or many data node. Name node is the master, as you see, it manages. Its job is to manage the data nodes. Okay. That means communication management. There are many other things. It also stores the metadata. What do you mean a metadata? Suppose the data I'm putting in here, the files I'm putting here, somebody needs to take care of that, right? Somebody needs to know where is what. Who keeps that there? Who keeps that information? Name node keeps it. So name node knows everything. Which file is where? Okay, so that when you request as a user where is the file, it will give it to you. So that information, which is called file system mapping, FS image. This is actually called FS image file. This is the metadata file. So it has 2 files, FS image and edit log. These are 2 files which name node manages. And through these 2 files, it knows where is what. Complete map. This file has 100 data blocks, and which block is where. The whole map is in here in this file. So that when you request something, name node goes into this file, find out where is what, gives you the data back. Okay, FS image, file system image. Edit log is as your file is changing, data is changing constantly. The changes are maintained here. I changed the file, added something, did something into the file. The changes are maintained here, and somehow they get synced up between this as well. There is another process. I'm not going detail into that. There's some checkpoint process and all that stuff, but the final image of the file is maintained. Process is there behind the scene, but it takes care of all your metadata. Okay. So name node takes care of the metadata, but actual data is in data node. Actual user data is here. Okay, the actual data is here. Name node does not store in data. That's the best practice. That doesn't mean that you cannot store it. You can store it, but nobody does it. So actual data, when I put it, the file gets broken down into multiple chunks, gets distributed and stored here. Name node keeps the metadata about the data, and if you request for something, it will say, okay, here is your file. Okay, you want to do something, you look at it. They will talk to the data nodes, get the information and from the metadata, and give the data back to you. Right? You need more data, you need more metadata to store, keep adding more nodes. Balancing automatically happens. If something goes down, it will not affect you because replication, the copies are elsewhere. So nothing, you as a user, you are not concerned behind the scene what is going on. Completely taken care by the framework. Okay. So I'm completely taken care by the framework. Okay. Then what happens? So HDFS. So this is your HDFS architecture, right? HDFS architecture, which has a name node, which has a data node, and all that stuff, right? And there is a communication between the nodes. There is all this, rebalancing happening, communication, heartbeat communication happening, all that stuff, right? So that's all good. That means when I install my Hadoop, put my HDFS software, kept it running, my files are safe. My files are distributed. I am safe, right? So,
So I take a quick question.
Yeah.
How is balancing different from scaling? Since they both almost the same thing.
I kind of heard you, didn't hear you properly. But balancing means you are rebalancing your data. Scale in, scale out is as you are adding more data, more nodes. Scale in, scale out is as your data growth happens, data need happens, you can scale out. That means I can add more nodes. As part of the scale in, scale out process, rebalancing happens. It's a result of scale in, scale out. If I'm adding 5 more nodes because I have to scale out, my data need goes up, the balancing will happen. So it's a result of your scale out, balancing happens. So it's a after effect of balance, after effect of scale out, or after effect of scale in, the balancing happens. You are adding 5 nodes doesn't mean that it just stays there. Balancing has to happen. So that's what happens. So balancing is a result from scale in and scale out. You got that? Yeah. So from software, we'll look at the actual platform tomorrow. Okay. So one of the thing you need to know, maybe because you were talking about Hadoop, I'm right. Their HDFS has, as I said, it's a framework, right? It's a framework. There are some framework or components. When you install Hadoop, there is something called libraries, right? All the Hadoop libraries come in. You install the libraries, which are, by the way, which are all Java based. You don't have to worry about, but that's how the Hadoop is written in Java, right? Those libraries get installed. There are some services run all the time, or the daemons, right? They run all the time. So you'll see a lot of the service. I'll show you tomorrow. You'll see HDFS services. There will be MapReduce services. All those things. So the services run all the time. It's a living, breathing platform. That means HDFS is a framework. It's a living, breathing framework. So you need to have some services running all the time, right? So that goes on. Then you will have config files to change the configuration of it. So I'll show that tomorrow quickly, right? There are some executable, so that as a developer user, you will be able to do few things. What are the things you can do? I want to file system commands. I need some file system commands because these are HDFS files. How do I deal with these files? Are they different from a regular Linux file? Yes, they are. But how do I work through that? How do I list file ls? How do I do look at the file cat, right? How do I do cp, mv, right? Create directory, all in HDFS. Okay, so typical what you call file system commands. Those are the only thing you need to know from HDFS standpoint. So you understood the concepts, you learned little bit of file system commands, you are good. Then we can get to the next one, MapReduce little bit. So that's all you need to know from the HDFS. We'll do a little bit of practice tomorrow, lab session. Okay, and I'll share the Hadoop virtual machine, okay, with you guys so that you can install it. But once you get to the AWS, you can do everything over there. Okay, EMR, it has EMR, so you can pretty much do everything in EMR rather than doing in here. Okay, So you can do that in here. So you can pretty much do over there, right? Once you are there, you don't need to go in, right? So we'll send you other thing we are going to send you is the steps to how to create AWS accounts. So right. So here you can go to EMR. I'm just telling you, right? You can go to EMR and can spin up my Hadoop cluster in 2 minutes. Okay, this is the ones I have terminated earlier, but I can create a cluster in 2 minutes. I can set up my, I can go to my advanced option and see. I can set my Hadoop Hive, Hue, all the stuff. I can choose my whatever I need, and I can get it ready in 2 minutes actually, to tell you truth. So here is a master. You see that master core. This is my just like name node and data node. I can choose how many I need, one master, 5, 10 or 2. I say go ahead and next and start. Within 3 minutes my server is ready on AWS. Okay, so these are something you will do later on, which will Bijay will show you, and we'll do more practice on here, but I was just showing you. Okay, so so those will go get there, but just wanted to show you this is readily available. But in the meantime, I'll give you a virtual machine just to practice. Since you will be practicing Spark a lot, I will give you a virtual machine. There you don't have to pay any money, because EMR is typically you have to pay. EMR is not free. It's not a free tier. Others are free. But again, it's not a lot. Okay, for our purpose, you just learn in the EMR, do the stuff, then shut it down, or not shut down, terminate it. Next time you just start it again. I'll say take 2 minutes to start one cluster. You run for couple of hours, maybe you paid few 20-30 cents or something like that, right? Something like that. Okay. Anyway, so this is something we'll learn tomorrow. I will not go beyond this at this point. I think people are also I set the expectation to 12 anyway, so I will not go much. So let me look at the any questions so far. You guys are okay till now? Okay. So again, we are going slow to start with, right? Just setting the context so that you understand what we are going to do. Also, again, our goal is not to be expert in big data here. But I want to give you a sufficient knowledge so that you can do your big data on cloud. That's our goal. Okay. See, our goal is not to be expert on everything to get a job. You guys, most of you who are looking for a job, again, also probably I need to get some information from you guys. Who are the ones who are getting to job market? Who are going all the way? You need to know and let me know, because I would rather work with very closely with folks, 3, 4, 5 folks, and place them rather than people those who not focus on that, right? Our goal as a company, right? We are here to build the people and place them, and even they do project in-house and all that. That's our goal. So we'll take you all the way from here to you are ready for the market, you're ready for the doing the work. Okay, that's our goal. So eventually I will see who are the people who are even in the last class. We didn't pick up everybody to market. We saw who are the people more serious, focused, who are the ones who are doing labs, promptly, who are not doing it. We saw the commitment from people, and based on that, we did eventually focused on 3, 4 people. We don't need all 100 anyway, right? People, those who focus on this. I'm not saying I'm not going to ignore everybody, but I'm saying that's what the expectation is. To as the labs come in, who are the people who are doing the lab? Who are the people doing Python? Who are doing all the platform engineering labs, right? Who are the people, right, getting more engaged? So we'll focus on those people later on. When the course is over, those are the people who will focus to get to the market, because we see these are people who are more focused. Okay. So Okay, so we'll not go further because I'm not bringing up the virtual machine right now, which I will do next tomorrow. Okay, I have a virtual machine I can spin up pretty quickly and show the whole Cloudera platform in 2 minutes. Let's do that tomorrow. Okay, and I'll give you this virtual machine to you guys. You can do it until you guys are on AWS, which will be another week or so. In the meantime, you can do your practice in here. Okay, as you study the Hive this week, and by Spark by next Saturday Sunday, you will be expert in Spark. We focus on few things and we'll go deep. Okay, so by next Sunday you will be expert in Spark. You can keep
So,
practicing.
Rati, where do we pay our attention to? Do we pay attention to getting, like, to practice Hadoop using the what do you call it, the VMware connection, or do we
No,
just
yeah,
use Hadoop inside of
yeah,
AWS?
doesn't matter. You don't know AWS at this point, right? So that's why I'm not. And AWS EMR is you are going to pay. It's not free. Yes, you are going to pay some money. You
You
know,
said
dollar
it's
to
40,
dollar.
you said it's still less than $1, right?
Yeah, a couple of dollars, $3, but you are okay with that. You can, but you have not learned EMR yet. It will be another 2 weeks to get there until Vijay comes to EMR. He is not going to teach EMR right from the beginning. He will start with EC2. He'll start with VPC. He will do a lot of stuff. By the time you get to EMR, another 2 weeks. Okay. In the meantime, if you want to practice this, since Spark takes a lot of time to practice, you would rather do that in a VM, virtual machine, in the meantime. Okay. But I'll show you on the AWS side if you want to do there. That also you can do. I'll show it as tomorrow as practice session. If you are okay with that, let me do that. Actually, let me do that way. So let me tell you how to practice on the cloud itself instead of virtual machine. That's okay. I think you can do that. It's few hours. That's okay. Few dollars. That's, you guys should be fine, right? Let me do that tomorrow directly on EMR. That's fine too. Okay. We'll do that. So I will spin up just a couple of notes, and we can do the practice over there. It's straightforward. Oh, okay. Okay. I think let's go that route. We'll do everything on EMR. Okay. Everything. But I didn't want to jump onto AWS without knowing, you guys not knowing, which is fine. But in the meantime, next few days, I'm going to send out how to create accounts. If you don't have AWS account, go ahead and create it, right? So that you get ready for doing lab sessions, at least for the Hive, Spark, and SDFS. Those are the 3 labs you will be doing this week: SDFS, Spark, and some Hive. Okay, these are the 3 things you will be learning by next Sunday. And also, you will Python. Python doesn't need a virtual machine or EMR. You will do that in the pie chart. Okay. So a lot of learning by next Sunday. Okay, a lot of learning by next Sunday. That's why we go, because we want to finish up. We want to set the foundation strong so that you can do, when you get to AWS data engineering, you will be able to do that. So that's the goal. There's a lot of expectation from you guys. It's not just hey, we are just teaching, I'm just teaching, but you have equally have to do it if you are looking to get. And if you do this sincerely, I can guarantee you can get a job. Next, when you start marketing Jan, in 2-3 weeks, you can, you'll get job. Okay. All right. Any other questions, guys, before we finish for today?
I just wanted to like speak about the virtual machine thing. Like earlier, I had downloaded that virtual box and was using Cloudera distribution. When I activated those Hive and other services, it stopped working on my computer. So yeah, I think that EMR route might be better, I guess.
Okay. Yeah. That's fine. Yeah, I'll go that route tomorrow. Will only thing you need to have I'll send out the instructions how to create account on AWS. In fact, Vijay is supposed to send it, but I'll go ahead and send it. And it has steps, right? So get that thing. Going to send out. I'll create one thing. I'll do. I'll create a Google group. The folks who joined today, and clean up my list because not everybody joined. So I'll clean up my list. Again, as I said, I'm looking for those 5, 6, 7, 8 people who are completely focused. Okay, just work on those. who are eventually staying with the course and going all the way, right? We'll send out the instructions and we'll continue, right? So yes, you can do on EMR. Downloading these big files, doing that, it's little hassle. But since we have cloud, we don't have to go with all this, virtual machines and all that. Okay. All right, guys. So again, this is just primarily. Okay, I know you're asking question. I'm sorry. So when are we going to do that? The big weekdays classes. I may do. So tomorrow we have the similar class at 9 anyway, and probably tomorrow we'll go with SDFS continue this thing on EMR. Right. I'll send out the thing today, and you can go ahead. It doesn't take to create an account. If you have AWS account, you can use it. Otherwise, you can create an account in 5 minutes, and it doesn't take that long. And that's all. You should be ready by tomorrow to do the lab along with me. Okay. In terms of classes, weekdays, I'm thinking of 3 days, 2 to 3 days this week. How about Monday, Wednesday, Thursday, or Monday, Tuesday, Wednesday? What days look? Again, we can change week to week. That's not a big deal. What days works out for you guys? 8 to 10 Central. So you can do either Monday, Wednesday, Monday. 3 days we will do. Monday, Wednesday, Thursday. Okay, we can do that too. Again, in some weeks, hey, we can change. Again, some weeks we may do just 2 days. So again, we are a little flexible on that. But weekends will be fully used. Weekdays we are doing it just to speed up the learning little quicker. Okay, because it's packed with a lot of technology, right? A lot of technology we are learning, but we want to maintain the continuity. Otherwise, it will be 10 days fine. Okay. So 8 to 10 time, 7 maybe too early. Maybe by the time 8 to 10 maybe okay. Yeah, 8 to 10. Sometimes we may finish a little bit early. That's okay. But goal is to keep learning something every day or every week. Okay, that's the goal. Incremental learning, and you keep up to date yourself to keep practicing. That will take you to the. There are a lot of things will be new to you. I have been doing this for years. Yes, I don't need to even look at any manual or documents. It's pretty much doing so many times. I don't need to look at anything. But for you guys, yes, it is new. But that's why incremental learning will be better. So that's why one step at a time, right? You keep on practicing. So okay, that's the goal. All right, guys. So okay, Monday we'll do Monday, Wednesday, Thursday. Okay, that's fine. First 4 weeks we do it at a fast pace. Then we little relax in the sense not every weekends. Vijay used to do a catch-up session earlier. We'll see how that thing goes. We'll see. Vijay, yeah, we'll see what is his plan once he. Yeah, PyCharm will PyCharm while we do Saturday or Sunday. One of those days we'll do. I'll give you the instruction how to install PyCharm and all that. And at some point we'll do PyCharm integration with Git repo. We'll PyCharm integration with PySpark. Those things also we'll do at some point, so that your DevOps answers questions you can answer, or you can practice a little bit how to check in and check out the what you call code that you write on PyCharm. Okay, that will be your environment for writing. When you go to interviews, hey, they will say, basically would say, hey, I've been building my programs in PyCharm, building my Spark in Python, checking into Git repo, and that's how my DevOps things works. Okay, so you'll do that as well. Python typically just 1 day. I very confidently I teach people Python in 1 day. It doesn't take that long for me, and 4 or 5 hours is sufficient for you to learn Python. Is there any link? Yes, I'll send all of the. I am going to send all the links for the Python steps, everything. Okay, so I'll do that. How to, and you can. Yes, it should be ready. So I think we'll do Python by next, sometimes maybe Thursday. One of this, since it takes 3 to 4 hours, maybe Saturday. I'm thinking, or next Saturday maybe. Okay, we'll see as we go. Okay, we'll finish up HDFS tomorrow. I'll also HDFS another 2 hours is sufficient. This is just the foundation, nothing much. We'll cover the map reduce very little bit. MapReduce is not important because MapReduce has been replaced with Spark. Okay, nobody is using MapReduce anywhere nowadays. So that's what we'll get the concept. How does it work? Okay, so I have all the document files for every as you see here. I have kind of class document for every tools, everything we are studying here, right? So only thing if you don't have Linux background, go do a little bit of practice. In fact, you do the practice you can do on EC2 instances or AWS. I'll show you tomorrow so that you can do some practice. So this is MapReduce, by the way. We'll go over that tomorrow very quickly. Our goal is not to get expert in MapReduce. Our goal is to go quickly, understand it, go quickly to Spark. Okay, so by Thursday or something, so 2 days, 4 for 8 hours, will completely focus on Spark, doing a lot of exercises. Okay, that's our goal. How quickly we get there, that's our goal. So that's why over the weekdays we'll cover this rest of the topics quickly, so that next Saturday, Sunday, that will be completely dedicated to Spark. Okay, so that you get when you have the good Spark knowledge, then you can, when you get to AWS, you can write those glue jobs in Spark, create my data cleanup job, all that stuff, right? You will be able. Now my last batch student, they did projects last couple of weeks back, and they build Spark programs using AWS Glue, right? So then those are the guys I'm marketing now. The ones who finished the project, those are the ones I'm marketing because I know these guys can do it. So that's how it goes. Okay. All right, anything else, guys? Otherwise we can stop here. Let me stop the recording and we'll see.